Hi guys, you're watching channel Mr. Electron, and this what you see is a three-phase rectifier which I made from a single phase rectifier and a few single diodes, and its capability is around 18 amperes. I uploaded its video a few weeks back. So today in this video I'm going to make a 35 amperes three-phase rectifier using two single phase bridge rectifiers with a maximum surge capability of up to 400 amperes. So guys, the first step is to keep the rectifiers together such that the text part is towards you. After that, take some metal piece with holes in it such that the hole distance for the two rectifiers matches the hole distance of the plate. Okay, then take some screws. Okay, and the next step is easy. Okay, remove one rectifier, place the bolt in the hole and bring it through the rectifier hole and just place the nut. Same for the other one. Now guys, comes the soldering, or you can see the connection part. You can see some kind of oil on the rectifier black part. That is WD-40 that I placed on the terminals to remove any possible rust that prevents us from better soldering. Well, I'm actually trying it. I'm not sure how it is going to turn out. Well guys, adding WD-40 was a terrible idea, although it didn't cause any trouble, but still it didn't work as expected. But this did, my Dremel tool. Okay, so let's clean the oxidation on the terminals. Well, try and use the Dremel and it will do wonders for you. You see how clean the terminal is when compared to the other one. You can see the oxidation on this one and how clean this piece is. Well guys, the removal of oxidation layer is complete now. It's time to do some soldering. Let's see how it performs now. You see how beautiful the soldering is working now, all because of the removal of oxidation layer. Okay, so comes the positive. Done. After soldering this wire, measure the length from here to here, because we are going to connect the positive terminal of this rectifier with the positive terminal of this rectifier. Okay, yeah, this much. So let's take it here. Yeah, if you use a thicker wire, it cuts a few strands sometimes. So guys, after completing the soldering for the red positive of the rectifiers, which came out really good, even better than I expected, comes the negative connection, which will be denoted by the black wire as always. Okay, now guys, since this part of the diode is positive, so its diagonal opposite, which is this one, is going to be the negative. So I'm going to solder the black wire on this negative terminal of the rectifier. And that's done. After that, the same thing for this one. Measure the distance of the black wire from here to the diagonal opposite of this positive, which is this one, again the negative. So I'm taking it up to here. Done. Now comes the stripping part, wire stripping. Still it's coming like this, which is not bad. Now guys, the rest comes easy and the soldering part is over. 3 input cables for 3-phase and 2 output for DC. So I'm choosing these 2 high current wires for the DC output, which will be our common output positive and negative. This red piece, you see this red terminal positive, okay, red wire will be connected denoting the final positive, and this one, you see the diagonal opposite, denotes the final output negative. And note that the links for the components used in this video for making this project will be provided in the description. If you want to buy them, you can check the links out in the description. Yeah, this is good. Same for this one. See, really strong. Done. So final output cables are done, positive and negative. Red positive, black negative, and also the output from positive and negative of this rectifier connected to this one with jumper cables. Now comes the AC input cables that are to be connected. So guys, these are the wires that I'm going to use for the three-phase connection. So for the first rectifier, which is this one on which these red and black cables are connected, the two terminals are open. Okay, you see this one is open and this one is also open. So simply connect two wires or connector cables on these. So that's for single phase. Now for the third phase, you see this one is also AC and this one is also AC. Choose any of the two and simply connect this cable and you have the three-phase input. So guys, our three-phase rectifier is ready for testing. Now guys, you have already seen my wind turbine generator, high current brushless three-phase output. Okay, so let's connect it to the rectifier. And guys, this is my 55 watts car headlamp bulb, which I usually use for testing alternators, motors and generators. Connected. Let's see. Yeah. You see it is glowing just by hand rotation. So the rectifier is working really nice. Let's do rope rotation. Well guys, I think that the rope was not long enough and also it was really difficult to pull the thread from that angle. So I've changed the camera angle and increased the length of the rope because the diameter of the pulley is really big. Okay, keep watching the bulb over here. Go. Yeah, now it's working really nice. So let's turn off the lights and do it once again. Now only the camera lights are on, rest is all turned off. Trying it the second time. Okay. Oh.
Thought bulb might have fused.
Let's make sure that it is not fused. Yeah, it is working. It was really bright this time. So our rectifier is working really good. It can handle huge currents now with a max of up to 400 amperes and continuous current of 35 amperes. And you can also use the 50 amperes diode. This is a 35 amps. Hi guys, you're watching channel Mr. Electron and this what you see is a Vanco KBPC 3510 bridge rectifier single phase with a maximum current rating of up to 35 amperes. So today in this video I'm going to modify it into a three-phase rectifier for wind turbine generators. So these what you see are diodes, okay, and each diode has a rating of around 6 amperes. So I'm going to use these to convert this single phase into a three-phase rectifier and with a current rating of up to 18 amperes. So guys, the first step is to make two sets of 3 diodes, okay, 3 on this side and 3 on this side. Let's keep these on one side. Now this gray side that you see, this indicates the negative. So what I'm going to do is connect all the negative sides of these 3 diodes together. Okay, so let's do that. So guys, the soldering part of the first set has been completed. All the negatives on one side and all the positives on one side. Okay, same for this set, all the negatives and all the positives. Now guys, both the diode sets have been completed. Okay, this is the negative side for all the 3 diodes and same for this one. So let's talk about this set. Okay, so the negative side of this set will be connected to the positive stated terminal of this rectifier. Okay, okay, let's move on to the next one. Now guys, in a rectifier, if this side is positive, then its diagonal opposite is the negative. Okay, so this one is the negative terminal of this bridge rectifier. So to the negative terminal, the positive side of the diode will be connected, which is this side. Okay, gray one is always negative, so the other side automatically becomes positive. Okay, so let's do that. Yeah, positive terminal of the bridge rectifier has also been connected. Now this one and the diagonal opposite, this one, these two are the AC terminals. So we will connect the wires afterwards, but this one to which the diode has been connected and this one to which the other set of the diodes has been connected, these two are the plus and minus output terminals for the three-phase DC rectifier. And since the output current is high, so I'm going to connect the wire of similar rating, okay, to this one and this one. So let's do that. So guys, here as you can see that I've connected the two wires to the positive and the negative respectively, and now comes the time for the three-phase AC terminal connection. The first one is going to be this one at which the diodes meet. Okay, this point, this will be connected first, and to this terminal I'm going to connect the red wire. So guys, now comes the final connection. Okay, let's turn this wire like this. Like this side is going to be the three-phase side and this side is going to be the DC high current output side. So two more wires are needed, which I'm going to use these. So let's take blue one. Doesn't matter which color wire you take, all of them are AC. So you see this terminal, okay, here as I showed you, it's showing the AC sign. So this will be connected over here like this, done. And this terminal black, this will be connected to the last terminal that is left out, and move it like this. Same for this one. And we have our 400 volts and up to 18 amps three-phase full bridge rectifier. So guys, the part one was about the construction of this three-phase rectifier, and this part, the second part, is going to be about its testing with the help of this three-phase brushless generator, which actually is a motor, but I'm going to use it as a generator. So guys, for the connection of the rectifier to the generator is simple. This and this, these three wires are the three-phase wires which will be connected to the three terminals of the three-phase generator. Okay, so let's do that. Done. Second also done. And yeah, so all the three wires from the bridge rectifier have been connected to the alternator, after which comes your multimeter. Now to the final DC output terminals from the rectifier, the multimeter pins will be connected. And first what we are doing is the voltage measurement. So giving it the simple hand rotation, you see 2 volts and no locking at all because there is no load, it's only voltage measurement. Let's see the maximum I can do with hand rotation. 5 volts. I think there were 5.1. So 5.1 was the max I could do. Let's move on to the rope testing. Keep watching the display screen. Okay, go. So as you saw, it was 24 volts DC maximum, no short circuit, perfect. Moving on to the load testing. Let's remove the terminals. Now here what we have is a 55 watts car headlamp bulb that I am connecting to the rectifier output terminals. Okay. So you saw that it was glowing, but obviously it was a little hard for me to rotate the shaft when it was under load. Okay, that was pretty bright. Let's turn off the lights and give it one more chance. I have turned off the lab lights completely and now only the camera lights are on. Okay, that was pretty awesome. Now guys, I have another better replacement for this generator. Okay, this is not actually a generator, it is a BLDC motor that acts like a generator when rotated, which is this one, a real wind turbine alternator, 400 watts. So let's do the connections, and obviously it is going to generate more power at the same input load, because the difference between a wind turbine generator and a BLDC DC motor is the matching between the number of stator and rotor poles. So guys, I've done a little change. I've placed the alternator on a vise and the 3 wires have been connected to the 3-phase bridge rectifier with output connected to the 12 volts bulb. Okay, so let's get on with the test. Okay, first I'm going to start easy. You see it is glowing pretty good. Now I'm going to put more power to the shaft, and I've also turned off the lights. And yes, increased the length of the rope because the pulley is bigger. Okay, go. Wow. You see that at the same power, I would say that it was a little bit easier than before. Once again. See. So this what you see is a flyback transformer from an old CRT TV. You see I have given additional center tap primary with thick copper coils, and this one is the final high voltage wire output, and this is the other terminal of the high voltage winding. So as we did in the UPS transformer inverter circuit, exactly the same we are going to do here. Done. Center tap is still open, which will be our positive input from the battery. Okay, and black is the same negative. The output voltage is going to vary from 10,000 to 50,000 max volts. Now guys, this blue wire is going to be our positive wire, and this positive wire will be connected to the center tap point as in my previous videos. Done. So that was simple. Now comes the connection of the negative terminal to this battery terminal, and the circuit should start working. Pretty good arc. Wow. So guys, there's one change that I'm going to do here. You see this 12 volts battery, I'm going to replace it with this 14 volts power supply, 12 to 14 volts, because I don't want to waste the battery power unnecessarily. Plus the second thing is I'm going to change the transformer. I'm going to switch from this transformer to my old UPS transformer. Okay, now guys, I've connected this transformer to the circuit, and there's one more change that I've done here. You see that I have connected this black jumper cable to the high voltage terminal, and this blue terminal is empty and white terminal is connected to this side. Okay, so guys, it's time to start the experiment. Just make your choice which one is going to melt, the drill bit or the iron nail. Okay, make your choice and let me know who was right in the comments. Whoa. Wow. Let's turn off the lights. You see it is so bright. Oh wow. I've never seen anything like this. Something is melting here. Weird sounds. Whoa, the nail melted red hot. That was a super cool experiment, guys. That's the nail. It had a pointy end initially, but now that is flattened, and there is a little melting at the tip of the drill bit also. Let's increase the gap. Wow, the ball is so big. You see, it is so bright. Okay, so guys, turning the circuit off and let's do the measurement. Getting ready. Okay, go. Whoa, 400 degrees. Okay, so guys, turning off the circuit and touching it to the heatsink. Okay, go. Whoa. It was 478 degrees. Now guys, we know that plasma temperature ranges to around 6000 degrees centigrade, and you see that it melted the tips of the iron nails, and the melting point of iron is around 1500 degrees centigrade. You see the tips completely melted, and you see this metal ball. This is one of the melted pieces. So you see that the temperature must be around 3000 degrees centigrade, or like at least 2000 degrees centigrade. Plasma temperature itself is around 6000 degrees, okay? But the temperature induced from plasma to the iron nails was enough to melt it.